This lesson covers the properties of multiplication. Again, these are the rules that tell us what it's okay to do and how the basic operation of multiplication works. And you'll see that these are an awful lot like the properties of addition that you've already learned. First, we have the commutative property. Again, we think about commuting, that is going back and forth. The analogy in the last lesson was that when you're going back and forth between home and school, the distance is the same no matter whether you're going from home to school or school to home. The commutative property of multiplication says that when you're multiplying numbers together, the order doesn't matter. You know this intuitively because you know that 3 times 5 is the same thing as 5 times 3. You know that it doesn't matter which order the numbers come in a multiplication problem. In general, we say that when we have two numbers, a and b, if we multiply them together, a times b, that's the same thing as b times a. Note that this works with long strings of multiplication problems. I've shown it above with just two numbers, a and b, but it works if we have 4 numbers or 6 numbers or 10 numbers all multiplied together. So for example, 2 times 3 times 4 times 5 times 6 times 7. This is a whole string of multiplication problems. I can switch the order of these around. I can turn this into 2 times 5 times 3 times 4 times 7 times 6, and the answer doesn't change. Changing the order within a multiplication problem doesn't change the result. Next, we're going to look at the associative property of multiplication. Remember, the associative property was about who you associate with. It's which clumps of numbers cluster together. The associative property of multiplication says that when you're multiplying 3 or more numbers together, it doesn't matter which 2 you multiply first. In general, if we have 3 numbers, and this works for 4 or 5 or 10 or however many, if we have 3 numbers, a times b times c, it doesn't matter whether we multiply a and b together first and then multiply our answer by c, or multiply b and c together first and multiply our answer by a, or we could even do this thing where first we apply the commutative property. We could switch around the order of these things. We could put a and c times b, and we could multiply a and c first and multiply it by b. It doesn't matter which 2 numbers we multiply together first. The answer is still going to be the same. Here's an example with some actual numbers to help. 2 times 3 times 5. Let's see what happens if we do this in a number of different orders here. If we multiply 2 times 3 first and then multiply our answer by 5, here's what we get. 2 times 3 is 6, and 6 times 5 is 30. Next, let's try multiplying the 3 and the 5 together first. 3 times 5 is 15, so we have 2 times 15, and that's also 30. Last, let's switch these around so that we have 2 times 5 first, that's 10, and multiply that by 3, and sure enough, we still get 30. Notice that no matter which 2 numbers we multiplied together first, our answer didn't change. Next, we have the identity property of multiplication. Remember, with addition, the identity property said that when you add 0 to a number, you don't change its value. Well, with multiplication, how do we not change the value of a number? We multiply it by 1. So multiplying a number by 1 doesn't change its value. 5 times 1 is still 5. Any number a times 1 is still a, no matter what a is. Now here's where we're going to have to be careful. We know that if we multiply by 1, we don't change the value of a number. But a lot of times, those 1s that we're multiplying by will be hidden in disguise. They might look like this, 2 minus 1. That's another way of writing 1. They might look like this, 3 over 3. 3 over 3 is 1. They might look like this, 1/2 times 2. 1/2 of 2 is 1. They might look like this, 3/4 times 4/3. If I multiply those two numbers together, I'd get 1. All of the numbers shown here are equal to 1. They might not look like it, but they are in fact equal to 1. And what that means is that if I take any of the numbers here, it'll work in the identity property of multiplication. So for example, if I took 5 times 2 minus 1, I'd still get 5, because 2 minus 1, that's just a 1 in disguise. If I took 5 times 3 over 3, my answer would still be 5, because 3 over 3 is just a 1 in disguise. If I took 5 times a half times 2, I'd still get 5, because a half times 2 is a 1 in disguise. You get the idea here. 5 times 3/4 times 4/3 is still 5. This idea that when you multiply something by 1, you get that number itself, the number you started with, is actually really useful to us when we can think about clever disguised ways to write 1. Okay, we need to pause for a minute here to introduce some vocabulary. You may have heard before the term multiplicative inverse. It's also called a reciprocal. And the easiest way to explain this is with some examples. So if I start with the number 5, the multiplicative inverse of 5 is 1 over 5. If I start with the number 1/2 or 1 over 2, its multiplicative inverse is 2 over 1, or just 2. If I start with 2/3, its multiplicative inverse is 3/2, 3 over 2. If I start with 0.25, I think to myself, gee, that's the same thing as 1/4, 1 over 4. Its multiplicative inverse is 4 over 1, or 4. The multiplicative inverse is the upside down. It's taking the number, writing it as a fraction, and then turning it upside down. So if you look at this table, if we start with the number 5, the way we can write that as a fraction is 5 over 1, and then we flip it upside down to get 1 over 5. If we start with 1 over 2, that's already written as a fraction. If we flip it over, we get 2 over 1, or just 2. 2/3 we flip upside down to simply make it 3/2. 0.25 we thought of as a fraction. We wrote it as 1/4. And flip that upside down, it's 4 over 1, or 4. The inverse property of multiplication says that when you multiply a number by its multiplicative inverse, it's upside down, the answer you get is 1. So let's look at the examples in the table from the previous slide. If we took 5 and 1/5, we said those two, that 1/5 was the multiplicative inverse of 5. If we multiply those two together, 5 times 1/5, well, let me write this out the long way. 5 times 1/5. To multiply fractions, I have to multiply the numerators together and multiply the denominators together. And so I have to write 5 as 5 over 1. So 5 over 1 times 1 over 5. On the top, I get 5 times 1. On the bottom, I get 1 times 5. So when I do that multiplication, 5 times 1 is 5, 1 times 5 is 5, I get 5 over 5. Well, that's just 1. So notice that I took a number, 5, I multiplied it by its multiplicative inverse, its reciprocal, and my answer was 1. I can do that with the next pair of numbers, 2/3 and 3/2. 2/3 times 3/2. Again, when I multiply fractions, I multiply my numerators together, 2 times 3, and my denominators together, 3 times 2. That gives me 6 over 6, which is simply 1. 1/2 times 2, when I multiply those together, I get 1. 0.25 times 4, if I multiply those together using the rules for multiplying decimals, I would get 1.00, which is just the same thing as 1. Notice that in all 4 cases, I multiplied together a number and its multiplicative inverse, and the answer was 1. This is the inverse property of multiplication, and we're going to use this one a lot this year to help us get rid of fractions in problems where it would be easier to not have them be there. Now I'd like you to try. Please pause this presentation while you copy and complete each of the 6 problems below. Your job is to figure out What goes in the blanks? The next is the property of 0. This simply says any number times 0 is always 0. A times 0 is 0, no matter what A is. 3 times 0, 0. Pi times 0, 0. 8.61438 times 0, 0. No matter what number we multiply by 0, whether it's positive, negative, rational, irrational, the answer we get is always 0. This is going to become important when you're doing algebra and you're factoring polynomial expressions. Next, we have the property of -1. This says that when you multiply a number by -1, you change the sign on that number. For example, if I start off with A and I multiply it by -1, then I get -A. If I start off with -A and I multiply it by -1, I get positive A. I switch the sign on the number. Multiplying by -1 switches the sign on the number. So 3 times -1 gives you -3. -4 times -1 gives you +4. So what about division? We've gone through all these properties of multiplication. Here's a question for you. Is division commutative? Does it matter which direction you do a division problem in? In your notes, I'd like you to explain, both in writing with words and use a math example, whether or not you think division is commutative. By now you're getting the idea that being able to explain your thinking in writing and examples in math is an important skill in this class. All right, last but not least, the division rule. The division rule says that dividing by a number is the same as multiplying by its multiplicative inverse. First, let's go through this with an example. Dividing by a half. Dividing by a half is the same as multiplying by 2, because the multiplicative inverse of 1/2 is 2. 8 divided by a half and 8 multiplied by 2 should give me the same answer. And in fact, they do. They both give me 16. If you're feeling skeptical about the fact that 8 divided by a half is equal to 16, you can try 2 things. The first is, get out your calculator and do 8 divided by 0.5. That's the decimal equivalent of 1/2, and you'll see the answer is 16. The other is you can think about taking 8 whole things, maybe 8 pizza pies, and you want to divide those 8 pizza pies into groups, and each group has a half of a pie in it. How many groups would you make? Well, you'd make 16 groups. This shows you that you can take a division problem and turn it into a multiplication problem.